Welcome to section 6 of OMI 302, Introduction to Production Management. Today we'll continue with what we started in the previous session, designing goods and services. We've seen what an effective design is, characteristics of an effective design, and what consequences there are if we do not have an effective design. Today we want to look at some functional activities of designing goods and services, why we need to have some functional designs. Now, so we want to consider the case of reliability. Now, we're going to assess reliability because, well, reliability is like, consider it as one of those quality dimensions that fall on both sides of the divide. You can find people assessing reliability of a service, reliability of a product. So it's a concept that really bothers on many what's it called, items of production in production perspectives anyway. Now, we're saying that reliability is the chance that a given product will perform its intended purpose for a specified length of time under normal conditions. Now, I like this part, normal conditions, because now, if you use the thing in some abnormal conditions and it turns out not to be reliable, you can't blame the producer. For instance, if you're supposed to use, let's say, a certain television set under certain temperatures and you do otherwise, it may not last you long. And when that happens, you can't say that the product lacks reliability. And so we want to say, put so much emphasis on the word normal conditions. Now, it says a product's reliability is a function of the reliabilities of its components. What we're saying is, for a product, for us to judge that a product is reliable, then it means that all the other component parts that come together to make the product must equally be working perfectly. So for instance, you take a phone and it's a touch phone. You want the touch software to be working well. You want the back screen or the screen to be working well. You want the light to work well. You want the ringtone. A lot of things. The battery must last long. When we put all of these together, then we can determine whether the product is reliable. Well, of course, if I have a phone and every other thing is working apart from the touch, I would say the phone isn't good, isn't it? So that's what we say. So when we say the product, is just we'll assess what this means. Now we can assess reliability or visualize reliability in a serial arrangement or in a parallel arrangement. Now, so when we say it's in a serial arrangement, we're just saying that it's like a horizontal arrangement of this thing. I'm sure we've seen this in basic school when we're looking at power and batteries, when you're arranging cells in serial arrangements and stuff. So under reliability here, a serial arrangement is just when you find the components arranged in some horizontal manner. But the second one, which is the parallel arrangement, is when you have something arranged one above the other, sort of. We will understand what this actually means anyway. Trust me, this concept is a very interesting one. But we're going to adopt some basic quantitative analysis to assess the reliability of product. Now, we say that for the reliability of a serial arrangement, we are saying that reliability for a product actually is the product of its component parts. So for a serial arrangement, it is just reliability of the first component by the second component to whatever number of components. So we say R for a product, which is RP, equals R1 times R2 times R whatever to Rn. You get it? So whatever number of components, we'll take all that one into consideration. That is the case of a serial arrangement. How about the parallel arrangement? We're saying that for reliability of a product that is arranged in parallel, then we say that the reliability of the first component plus 1 minus reliability of that same component times the reliability of the second component. Think about it like a backup. Now let's explain this. Let's re-say this in let's say qualitative sense. What we are trying to say is that to find the reliability of a product arranged one on top of the other, it's like looking at this one as the main one and then the other one on top of it as the backup, sort of. So think about it. You have a home, you have a business, you take power from ECG, the national grid. Now we're saying that I can also have a backup generator that will kickstart when I lose power from ECG. So all we are just saying is if I have this as my normal one, I can have another one which is a subsidiary to the main one. Now in the event where this one fails me, I'll fall onto this one. So that's what the parallel arrangement says. So I'll go back one step for you to just see this. So you see it. There's R1, and on top of R1 we have R2. Okay, coming back here. So what this is saying is that, so if I want to find the reliability of that product in entirety, then what we're saying is reliability of that product plus chances that that product fails. So we'll call that the probability of failure. You know, if you remember your basic probabilities, 1 minus the probability is the complement of whatever original probability you have. So we say this is 1 minus the reliability of that first component times the reliability of the second one, which is the backup. So this but we're saying that, see, the more the components, the higher the number of components, the lesser the reliability. So I'm saying that, so in the comment you do see that we say this makes a good argument for simple designs with fewer components. In fact, you know, keep it simple and life will be simple and the product will last longer. Now, previously people go like they relish the days they used to use Nokia 3310 and those other brands of phones then. They barely had anything, you know, it was just to make voice calls and, you know, some funny ringtones, and that's it. So robust. When they hit the ground or the floor, you hardly would find anything significantly going wrong with them. But in current times, we have a lot of components imbibing the kind of phones we have. The touch screens, the cameras, the records, the radio, torchlight. A lot of interesting stuff. And so the moment the slightest something happens to it, you know, and so you notice that we can consider those old phones as relatively more reliable compared to these ones, but they lack some features. So we say, well, but the fewer the components, the higher the reliability. Good. Now we're also saying that reliability can also be expressed as the length of time a product or service is in operation before it fails. So we can see reliability. Now, in the first instance, all we're looking at was computing the component reliability of individual products. But, you know, generally we can understand reliability from another perspective, where we say we can look at the system's average availability to assess what the reliability. So on the average, right, how available is my system, is whatever system that I have. So when we use some pointers, we have two techniques that we adopt in helping us understand this second aspect of assessing reliability. We have what we call the mean time between failures. Now, how do we understand what this mean time between failures? It's like saying the average time between the number of times the product fails. So for instance, I can have a certain watch. I use it for 6 months and it breaks down. I get to repair it. I use it for another 3 months, it breaks down. Then I get to repair it. I use it for another, let's say, 12 months and I get, so all these times, when I put the length of time, all these different times that it worked before I had to repair it or do something about it for it to get working again. When I put all these times together and find the average of it, I refer to that as my mean time before failure. But we can also see it as 1 over the failure rate. And then how do you find the failure rate? Your failure rate is just the number of times and the time over the number of failures. It's very basic mathematics here. So for instance, say if your laptop fails 4 times in 20 hours of operation, the failure rate is the number of times it fails over the number of what's it called, the time available. So here we are saying that, so it fails, my laptop fails 4 times, so that is 4 times over the number of hours, which is what, 20 hours, and that's my 0.20. So that is my failure rate. So 1 over my failure rate would give me my mean time before failure. Now, so the next aspect is what we call maintainability. So we are saying that we can assess the average time which our system is available by its reliability, the average reliability And then the second part is the maintainability. This is also, so though, let's just, forgive me, but understand what we mean by maintainability, the ease with which we can maintain. So it is the ease or the cost with which a product or service is maintained or repaired. That's simple. Maintainability, how easy it is to maintain a product, or how easy it is to get it repaired in case it breaks down. Now, so normally you find organizations providing self-helps in the manuals and stuff. So they provide instructions that teach consumers on how to anticipate malfunctions and correct them themselves. So you buy gadgets, and in the manuals they tell you, when you see this, this is happening. So do this, do that. These are all measures of improving maintainability. But we said one quantitative measure of assessing maintainability is the mean time to repair, which we call the MTTR. Again, it's also the mean time to repair is just making reference to, now, for instance, like the watch example I gave. If I were to take my watch to the repair and it takes 2 days before I get it back, then another time it takes 3 days, another time. When I put all these times it takes between getting the product or the watch to the repairer and how long it takes to repair it, and I put them all together, right, generally, and then I find the average, that gives me the mean time to repair, right, the average time it takes to get my item repaired. So when we combine these two characteristics, the mean time before failure and the mean time to repair, we have what we refer to as our system's average availability, and that is another measure of reliability. On the average, how long is my system available? So so for your system's average availability, we say that it is expressed as the mean time before failure divided by the sum of the mean time before failure and the mean time to repair. So let's consider an example. So Rejoice must choose a service provider for a company's e-commerce site. So other factors being equal, she will base a decision on the server availability. So the information is provided here in the data. So we have providers A, B, C. Now the mean time before failure in hours for provider A is 72, for provider B is 56, and C is 42. The mean time to repair in hours is 8 hours, 5 hours, and 3 hours respectively. So you can easily just do this and compute. So for provider A, it's just going to be your 72, which is the mean time before failure, divided by 72 plus 8.0, and that gives us 0.90. Now, if you do the same for the 3 service providers, obviously the one with the highest systems availability or service availability should be your choice. And so for A, we had 90%, for B, we had 91.80%, and then for C, we have 93.33. So in making a decision, Rejoice should choose provider C. So there are other examples in the recommended text in Russell and Taylor, the 7th edition. So you just go to page 185, and you can look for these exercises, exercise 4, 13, 4, 14, and also on page 144, exercise 4, 14, and 12. Then you'll be fine. You have lots of examples to try. Okay, and then usability. Another characteristics or functional characteristics of a product is, when I prefer to start from this. We have all encountered products and services that are difficult and cumbersome to use. Have you visited a website where you get there, you don't even know what to click or what to expect, or an application system where you don't even know how to upload the documents? Sometimes some services could be so complex to access, so complex to use, said that you just give up. So that is the component of usability, the ease with which I can use the product. So it's a combination of the user's experience, the ease of learning, the ease of use, and then the ease of remembering how to use. Sometimes you may just have to be tutored over the process of doing the same thing over and over again. It may not necessarily be your fault, but it is just how complex the system or the product has been made to be. And so then when it happens like that, it takes away that, fun or that essence of a customer wanting to really use the product, and it affects quality of the product. Now let's look at another aspect of designing services. Now we need to understand what the service is and what some characteristics of a service is or are. So we say services are acts, deeds, performance, or relationships that produce time, that are produced at time, place, in a form. So for instance, cleaning service saves the customer time. You understand? Now, department, stores, online broker puts together information, in a form for suitable for the investor. You can really track the performance of all firms day in, day out. You may not have the time, but the broker does that on your behalf, and he gives you every information and just gives you the necessary, what is important. This guy is doing well, and so it comes in that form. So services come in within time, in a place, and or probably in some forms. Now then, services are intangible and perishable. Intangible, you don't touch them, you don't feel them, but you don't see them, you experience them, sort of. Okay, and they are perishable. Now, it is more comprehensive and occurs more often than product design. Yeah. Now, we're saying it is more comprehensive and occurs more often than product design because services are unique. Every customer comes with a unique expectation, unique experience. And so, it's not that easy, like the way we can just have one blueprint for producing on mass basis or some continuous product. Services really need some, extra dimension, extra touch to always make it unique for each customer. Now, the first stage is the service concept, the purpose for the service. Now, why are we getting into this? Why are we producing the service? Who needs the service? So it defines the target customer and the desired customer experience. How our service is different from others. And then how it will compete on the marketplace. All these put together would give you the service concepts. Now, so in coming out with a good service design, we consider a lot of things. The sensual benefits, the psychological benefits, the physical items. Although these, for instance, the physical aspects the customer doesn't specifically or touch them or experience them, and they play a critical role in the service. For instance, if you take the case of a restaurant. Now, these components could be found in the facilities, food, the drinks, the tableware, napkins, and you look at these things, they are not part of the food you're going to eat, but it sets a certain ambience, a certain environment, and you can judge. So the sensual benefits like the taste, the aroma of the food, sometimes the aroma of the food could just invite you in. But if it's just they don't mind and it's some, kind of choky aroma, you will not want to move in that dimension. Now, the physiological benefits, the rest, the relaxation, the comfort status, and then a sense of well-being. All these things come together to form the service package, like you said. Okay. Now, so we develop the next thing in the service design is also develop the performance specification for general and specific customers. So, service specification. What are the things that we think should be put in place to ensure this expectation is met of the customer? So, and we get that from the customer's requirements and then their specification. Your customer comes and tells you, I don't want too much pepper, I don't want this. How do you know this is too much pepper, this is not too much pepper? All these things come into play with the requirements of the customer, and we're able to set those. Now, we also develop design specifications, which must describe the service in sufficient detail with the desired service experience. Now, what this I'm saying is, you see, because services are that unique and do not, are not so specific, every customer has some level of varied expectation. Our specifications would be sufficient, but we cannot say it is the absolute one. Okay, so they usually consist of activities to be performed, the skill requirements, guidelines for service providers, cost and time estimates, facility size, location, and layout equipment. Now, for these things, you can specifically tell, what exact skill set is required for this, because everyone, for instance, let's consider skill requirements. There are some instances where if you're looking directly in the face of a customer and talking to them, some people may consider it as rude. There are instances where you may want to shy off and not really gaze into the face of the customer, and some other customers will think they don't have your attention, and again that becomes a distance. So how do you form the balance? So we can always have sufficient detail for what we do, but we can say they're absolute. Okay. So, and then finally we can also develop service specifications, which should outline the steps required. So we can have work schedules, deliverables, location at which work is supposed to perform, and all these put together come to form the service design process. Now, what are some of the tools for service design? So we look at the quality function deployment, which I think we spoke earlier on in the total quality management session, which is a tool that uses, we derive customer. It's like it speaks the voice of the customer. You take customer requirements, use certain matrices to rank them against our performance, against the performance of our competitors, and then come out with a complete framework as to how whatever the customer wants culminates into the product or the service that we give them. Now, the service blueprints also are specialized flowcharts as to how we are going to offer our services. So it gives us a layout as to how services or how our service is supposed to be given or offered. And then service scripting, specific choice of words and certain ideas that we use. Now, for instance, you call an organization and the front desk executive picks up and say, "Hello, this is so and so business. How may I help you?" These are all ideas or scripts that have been written and mastered by these people for them to ensure that the customer has the best experience. Service keeps the design of the physical environment. You notice that some organizations want to have a certain look or certain design specifically, irrespective of where it is found. Take a typical example of Total oil company. Over time now they've rebranded, so they have this red and brownish color and this simple touch to all filling stations that are under Total brand name or the Total franchise. That is a service cape. How their physical environment will look, how they want the buildings, the colorings and everything. And then waiting time analysis, how long we also expect our customers to wait for a service in the queue and even in the system and all that. I hope this was helpful, and we'll see you in other sections. Thank you.